All right, so we're going to focus on solving quadratics by factoring. This goes underneath our solving quadratics algebraically standard, or it lists out the different methods that we're going to use. This is just one of the methods that we're going to cover, but in my opinion, it is probably the most important method. Now, factoring is just another way to say that we're going to undistribute. It is the opposite of the distribution property. And whenever you are factoring, you always have to have things in standard form. We've talked about standard form before when we're graphing. Standard form is ax squared plus bx plus c. And we are going to refer to the a, b, and c quite a bit when we are factoring and solving in other methods as well. There are two methods that are listed here for you for factoring. I am going to use the box method for all of my examples. But if you know another method, you're more than welcome to use that method. I've also listed the second method down here, 5-step method. That's the one that's also taught by some of the math teachers up here at the high school. So you may already know that method if you remember how to factor from Algebra 1. No matter what method you use, the first step is always the same. And in fact, when we look at the two different methods that we have listed here, the first 3 steps are the same. So a lot of these methods are going to overlap. There's just probably a different way to lay them out. We're going to take a look at box method. I'll come back to what this chart stands for in just a moment when we're actually working through a problem, but we're going to take a look at the first problem here. So in this first problem, we have something written into standard form. We know that we have to solve it because it's set equal to 0. And we need to take out a GCF. That is a greatest common factor. So we are looking at these numbers in front of X and the number that's by itself here. And we are going to see, is there a number that goes into all 3 of these? And there is. That number is 2. And when I take 2 out of all 3 of these parts, I'm left with x squared minus 12x and plus 32. When I say take out, we are really saying we're dividing out. Remember, factoring means to undistribute. And when you distribute, you're multiplying. So the opposite of that would be you're dividing out a number. Once you've done this, it's time for you to label A, B, and C. Now, there may be some times that we'll see in the future that didn't have something to take out. And that's perfectly fine. And you really don't need this equals 0 here. That's just there to kind of remind us that, hey, we are actually going to be solving this in the end. So if it confuses you, you can take it out. But to label A, B, and C, we'll find A in front of the x squared term. So if there's nothing written, that's 1. B is going to be in front of the x term. So that's negative 12. And C will be off by itself. If you're following along in the steps that we wrote down on the previous page, well, I guess that were written down for you on the previous page, then the next step would be to find A times C. So in this case, we're doing 1 times 32, which is 32. And once you have done that, it's time for you to actually find all of the factors. And if you remember, factors are numbers that multiply to equal a number. So the factors of 32 would be 1 and 32. And I encourage you to write these in order. 2 and 16. That way you won't forget them. 3 does not go into 32, so we'll go to 4. 4 and 8. 5 does not go into 32, and neither does 6. So these are the only 3 sets of factors that we have. Here's what I call like an X puzzle. And a lot of times I'll use this the first few times, but once you get really good and you know what you're looking for, a lot of students choose to skip this method of writing it out more visually. You still have to go through the process. You just might choose to not write the X later. But in the X, Our AC number goes up top. And then this number on the bottom is our B number. And what this is trying to tell you is that we are trying to find a pair of factors, like what we listed here, that multiplies to equal AC, but adds to equal negative 12. So to do that, we need to take a look at our signs of our numbers, because there can be any number of things. You could have 2 positives, you could have 2 negatives, 1 positive, 1 negative. There's a lot of different options. And some of them are going to be more obvious, and some of them are going to be less obvious. You may actually, depending on your signs, have 2 different options that could work. So don't just look at them and be like, oh, well, if I make this one positive and negative, it'll work. You really need to think about what signs are appropriate that will keep the multiplication one positive and the division or the addition one negative for this one. And that's where this factoring flowchart kind of comes in. It's not something that you would necessarily consult every single time. You'll do it enough that you eventually don't need to look at this flowchart anymore. But the flowchart is asking, what is the sign of the very last number? So that's our C number, which was 64. It's positive. So that means I can either have 2 positive factors or I could have 2 negative factors. And the sign of our middle number, that's the B number, was negative. So that means I have to have both of my factors to be negative numbers. So when we have our little chart here, we're going to make all of our factors negative. And then we'll check to see which pair adds to equal negative 12. And the correct pair would be negative 4 and negative 8. I really encourage you, especially if you choose not to use that flow chart, I really encourage you to mentally at least check, does negative 4 times negative 8 really equal positive 32? And negative 4 plus negative 8 really equals negative 12. Even if you just do that mentally, it's really a good idea for you to do that. So once you have your pair of factors, it's time for you to fill in your box. And this is where the methods kind of differ between the 2 methods that are written on the first page of the notes. We fill in our box by putting in our first term here, which was x squared, and our last term here, which was 32. And these 2 boxes here are reserved for our factors, and we always add the same variable that we had in the middle term. So negative 4, negative 8, and the middle term had an x, so these 2 get an x. And what can I take out of this top row? I can take an x out of both of them. What can I take out of the bottom row? I can take a negative 4 out of both of them. What can I take out of the left side? I can take an x. What can I take out of the right side? I can take negative 4. Your answer comes from the GCF and then the factors that were outside here. X minus 4, and oops, this should have been negative 8. I can take a negative 8 out of both of those. So x minus 8. I know it seems like a long process and it seems very confusing at first, but you're going to do this enough times that eventually it will become second nature. And if I had to pick one single thing that we learn this year that you'll need over and over and over for the rest of the year and even continuing on into Algebra 1B and beyond, it's factoring. So make sure that you take the time to learn how to do this factoring. So for this, we're going to look for our GCF first. So a number that goes into 18, 21, and negative 4. And there's not a number that goes into all three of these numbers, so I don't have a GCF to deal with. Now we'll take a look at our A, B, and C. So A is 18, B is 21, and C is -4. So A times C is going to be a little bit bigger of a number this time. So 18 times -4 gives me -72. So now we write out the factors of -72. And I don't want you to worry about the negative right now, because that's what our signs flowchart is going to do for you. So 1 and 72. 72 can be divided by 2, and you get 2 and 36. 72 can be divided by 3, and you get 3 and 24. 72 can be divided by 4, and you get 4 and 18. 72 can't be divided by 5, but it can be divided by 6, 6 and 12. And just go down that line on your calculator. I really recommend you go in order. Don't be flipping around, because you're likely to forget one. And that one could be the one that you need in order to make it work. And the last one was 8 and 9. Once you kind of get to the number that you have in the right column, you're all done. So it's time for you to look at that factoring flowchart. So what was the sign of our last number? It was negative. So we'll follow it down. That means we have to have one positive, one negative. The sign of the middle number was positive. So what does that tell me? It tells me that the larger of the two factors is going to be positive. So when we have our listing of factors, because we did them in order, it makes my life really easy. This second column here has to be positive, and this first column is going to be negative. So what multiplies to be -72, but adds to be 21? And you're going to look down your list over here and find the one that works. -3 and 24. And just do at least a mental check. Does -3 times 24, does that equal -72? And it does. -3 and plus 24, does that really equal +21? And it does. So a mental check is all you need. You don't really have to write that down every single time. So to fill in our box, we have the first term, 18x squared, and the last term, -4. And the middle term will be replaced by the two things that added to equal it, -3 and 24, and they'll both get the same variable that the middle term had. So what can I take out of this top row? I can take a 3, and I can take an x. What can I take out of this bottom row? I can take a 4. What can I take out of the left side? I can take 6 and an x. And what can I take on the right side? It doesn't seem to be anything in common, so I can just take a 1. Now, I want you to be very careful. I did make a mistake here on purpose because I wanted to show you the benefit of using this square over the other method. In this square, you can do a quick check to make sure that you are taking the right numbers out, because all the outside numbers will multiply to be the inside numbers. 6x times 3x, 18x squared. 3x times 1, it's supposed to be a -3x. I don't want to change this 3x because that would change and make my 18 the wrong sign. So instead, I want to make this guy negative. Let's see if it works for the rest of it. 6x times 4, 24x. 4 times -1 gives me a -4, so it definitely works. I did not have a GCF here, so my answer is just 3x plus 4 and 6x minus 1. So that's the benefit of factoring, and in just a moment we'll go back and we'll actually solve both this problem and the first problem, but I just wanted to give you a chance to see the factoring part first. So when we are solving, so we did the factoring, when we are solving, we are taking each of these factors and we are setting them equal to 0. So that means that we have to actually solve this out by subtracting 4 from both sides and then dividing by 3. So x equaled -4/3. And then here we added 1 to both sides and divided by 6. So the other solution was 1/6. And in the previous problem, I didn't have a number in front, so it made it really easy for me to find the solutions. X minus 4 equals 0. X minus 8 equals 0. Add 4 to both sides so that x equals 4. Add 8 to both sides so that x equaled 8. All right, we've got several more problems to work through. As soon as you feel like you've got a hang of this factoring, you don't have to continue to watch the whole rest of it, except for, I just want to caution you really quickly, make sure that before you factor, you have made it equal 0. So that means on these bottom problems here, you're going to have to do a little moving around before you start this process, just as a word of warning. But as soon as you feel like you have a hang on this, feel free to go ahead and start working on some problems on your own. So number 3 is a great example of one that's not in a form ready for me to do factoring. I have to actually subtract 30 from both sides. So I have 2x squared plus 7x minus 30 equals 0. So my first step when I'm factoring is to check, can I take something out of all the pieces? And I can't. Both 2 and 7 are prime, so nothing would be common in all of them. So that makes my A 2, B 7, and C -30. That makes my A times C -60. So the factors of 60, you're going to go down the list. 1, 60, 2, 30, 3, 20, 4, 15, 5, 12, 6, and 10. 7 doesn't work, 8 doesn't work, and 9 doesn't work, and there's 10. So that's all of the factors. If you look at your factoring flow chart, the sign of my last number was negative. So it means I want 1 positive and 1 negative. The sign of my middle number is positive. So that means that my larger factor will be positive. So all of these will be negative. So what does it multiply to equal? -60. What does it add to equal? 7. So let's find the one that multiplies to equal negative 60 and adds to equal 7. Right here it is, negative 5 and 12. So mental check, negative 5 times 12 is negative 60. Negative 5 plus 12 is positive 7. So I know that this works. Time to fill in my puzzle. First term, 2x squared. Last term, negative 30. And then my negative 5x and 12x. So what can I take out of the top? 2 and an x. What's common in both of these? Meaning what can they both be divided by? A negative 5. Now how did I know it was negative? Well, a hint is that if the box touching the outside is negative, then what you take out will also be negative. And remember, if you don't remember that, it's always a good idea to check it and you'd be able to catch it then. So what can I take out of the left side? There's nothing in common except an x. And the right side, I can take a 6 out of both of these. Let's double check and make sure that they all work. 2x times x, 2x times 6, x times negative 5, and negative 5 times 6. They all work. So then my answer is 2x minus 5, x plus 6. That's my factoring answer. My solution comes from setting each of these equal to 0. 2x minus 5 equals 0. X plus 6 equals 0. So we'll solve this by adding 5 to both sides. And then divide by 2. So x is equal to 5 halves. And then subtract 6 from both sides. And we get that x could also be negative 6. We're going to walk through 4 more problems. So this one, there's nothing that's common for me to take out. So A is 1. B is actually 0. And C is negative 36. So A times C equals negative 36. 1 and 36. 2 and 18. 3 and 12. 4 and 9. 6 and 6. There's all the factors. If you look at your factoring flow chart, the sign of your last number is negative. The sign of your B or your middle number can be either positive or negative because it's 0. But which means that we have to have the larger factor be either positive or negative. We want it to add to equal 0. So negative 36 is what we're trying to multiply to be. 0 is what we're trying to add it to be. So the only one that works is negative 6 and 6. And if I check it in my head, it works. First term, last term, and we'll have 6x and negative 6x. What can I take out of the top? X. What can I take out of the bottom? Negative 6. The left, x, and the right is 6. So x plus 6 and x minus 6 are my factors. And I want to draw your attention really quick. So I showed you the long way, which I sincerely hope for this type of problem, because it is a special kind of problem I'll talk about in just a second. I hope that you never have to walk through the long way, because I hope that you remember that with two terms that are both perfect squares with a minus sign in the middle, that they follow that difference of squares pattern. They will always factor down to be the square root of the first term, x, the square root of the last term, 6, and the signs will be 1 plus and 1 minus every single time. As a matter of fact, we're going to write down the difference of squares pattern on the previous page so that hopefully you will remember it and not walk through that long method, because it takes valuable time that you need, and that 0 in the middle really tends to confuse people. So when we talk about difference of squares, we'll have two perfect squares and it has to have a minus in the middle. That is a must. If it does not have a minus in the middle, then it is not a perfect square. Or sorry, it is not a difference of squares. So you must have that. And if you do have difference of squares, it will always factor down to be the square root of the first term in the first box, the square root of the second term in the second spot, and one will be plus and one will be minus. Three more. Okay, so in the first one here, we're going to look to see, can I take something out of both pieces? And in this, I can take a 6 out of both, and I can take an x out of both. So when I do that, I'm left with a 2x, and I'm left with 3. Now you might notice that once what was left did not have any exponents. If there's no exponents, there's no need to go through factoring. This is already factored form, which means to solve it, we would take our 2x minus 3, set it equal to 0, and our 6x equal to 0, and solve it out. So add 3 to both sides, and divide by 2 on both sides. And we get x is equal to 3/2. Divide by 6 on both sides, and we get that x is equal to 0. Last two. So again, this is not set up for me to do factoring off the bat. I have to subtract that 2x from both sides. And put it into standard form. So 12x squared minus 2x minus 2 equals 0. Can I take something out of all the pieces? Yes, I can take a 2 out. And that leaves me with 6x squared minus 1x minus 1. And so when I label A, B, and C, it's coming from my part that I took the GCF out of. 6, -1, -1. So A times C gives me negative 6. Factors of negative 6, or factors of 6, 1 and 6, 2 and 3. And if we follow that factoring flowchart, the sign of my last number is negative. So I have 1 plus 1 minus, and the sign of my middle number is also negative. So my larger factor will be negative. So my larger factor is negative, and it's going to multiply to be a negative 6 and add to be a negative 1. So that makes 2 and negative 3 the one that I want. 2 times negative 3, negative 6. 2 plus negative 3 is negative 1. So I know that it works. First term. Last term. 2x, negative 3x. I can take out of the top row not only an x, but a 2 as well. Out of the bottom row, the box touching the outside is negative, so I'm going to take a negative, and there's nothing in common, so negative 1. Out of the left side, I can take a 3 and an x, and out of the right side, I can take out nothing in common, so just a 1. Double check. 2x and 3x, 2x and 1, 3x times negative 1, and negative 1 times 1. And they all multiply correctly into the box. So my solution for my factored form is the GCF I took out at the beginning, 2x minus 1, and 3x plus 1. So to solve, we'll set each one of them equal to 0. 2x minus 1 equals 0. 3x plus 1 equals 0. Notice I never set out my GCF equal to 0 unless it has a variable in it, because 2 equals 0 doesn't make sense. So we'll add 1 to both sides, and we get 2x equals 1. Divide by 2 on both sides, and we'll get that x equals 1/2. For the other one, we'll subtract 1 from both sides, and 3x equals negative 1. We'll divide by 3 on both sides, and x is equal to negative 1/3. So there's my solution. For our last problem, we'll need to add 72 to both sides. So we'll have 2x squared minus 24x plus 72 equals 0. What can I take out of all of the pieces? Well, lucky for us, because 72 is kind of a scary number, we can take a whole 2 out of there. And that leaves us with x squared minus 12x. And then 72 divided by 2 is 36. So plus 36. A would be 1. B is negative 12. C is 36. So A times C is 36. The factors of 36 are 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. Look on your factoring flowchart again, and we have the sign of our last number is positive. So that means we can have 2 positives or 2 negatives. The sign of the middle number is negative, so we want 2 negatives. So multiplying to be 36 and adding to be negative 12 means that I'm looking for negative 6 and negative 6. Negative 6 times negative 6, positive 36. Negative 6 plus negative 6, negative 12. So this checks. So we have the first term, which is x squared. The last term, which is 36. And then the middle term is made up by negative 6x and negative 6x. What can I take out of the top? X. What can I take out of the bottom? Negative 6. I know that I'm taking a negative out because the one touching the outside was negative. What can I take out of the left? X. What can I take out of the right? Negative 6. Quick check tells me that I know that all the outsides multiply to be the insides. And x minus 6, x minus 6, and don't forget about your GCF you took out in the beginning. So there's my factored form. The solution would be putting x minus 6 equal to 0 and x minus 6 equal to 0. Add 6. And you get that x is equal to 6, which you can write twice, but you're not required to write twice.